Okay, welcome to lesson 1 of this waves topic on acceleration, and I'm going to be doing this in 2 parts, and this is part 1, describing and using the equation for acceleration. The key words have been highlighted: acceleration, velocity, deceleration and speed. So if you can make your way through the knowledge check by pausing the video, and then we'll go through the answers. Okay, hopefully you've managed to make your way through that knowledge check. These equations, you do need to know them, and you do need to be able to rearrange them, as they will not be provided for you on the physics equation sheet during your exam or test. The equation that links distance, velocity and time. Distance equals velocity times time, or you could have velocity equals distance over time, or time equals distance over velocity. The equation that links voltage, current and resistance. Voltage equals current times resistance. Again, this can be rearranged. Weight equals mass times gravity. Charge, current and time. Charge equals current times time. Pressure, force and area. Pressure equals force divided by area. The equation that links force, work and distance, work done, is force times distance. And the equation that links density, mass and volume, density equals mass divided by volume. The last question on the knowledge check asks, what is the resultant force on an object moving at a constant speed? If it's moving at a constant speed, it means that the forward force is equal to the constant force, or the backward force, sorry, and the upward force is the same as the downward force. Therefore, the resultant force must be 0 newtons. Give yourself a square root of 8. You do need to learn these equations. I cannot emphasize that enough. They will not be given to you during your exam. Okay, so for the first part of this lesson, we are going to look at describing acceleration. And we're also going to look at the equation for acceleration and how to use it. Okay, so when I think of accelerating, I think of something getting faster. Okay, and that is true of acceleration. But it's how quickly it gets faster or slower. Okay, so velocity is speed in a straight line. So if velocity is speed in a straight line, it will have both the size, i.e. the speed, and it will have direction. So velocity is a vector because it has both size and direction. Acceleration is the rate of change of velocity of an object. Now that sounds really complicated, I think. I don't like it. Okay, so another way of looking at it is that it is a measure of how quickly the speed is changing, or the velocity is changing. Okay, so if an object is getting faster, it is accelerating, and if an object is getting slower, it's decelerating. So decelerating. Just a few quick notes to add on to the side. The quicker the velocity is increasing, the greater the acceleration. Another way of thinking about that is if you're driving a car. So if you're driving a car and you accelerate, to accelerate you must press the accelerator pedal. If you press that accelerator pedal hard and quickly, then you will accelerate quicker because the speed will increase quicker. If you press the accelerator pedal gently, you will accelerate slower, so therefore the velocity will increase slower. So it's all dependent on how long it takes for that velocity to change. So acceleration is change in velocity divided by, because that's what this line means, divided by change in time. You do need to know this, okay? So highlight it, star it, whatever it is to make it stand out to you, but you do need to know this equation. Okay. So sometimes it can look like this. Your A is for acceleration, change in velocity over change in time. So that delta symbol there just means change. Okay. Units are really important. So acceleration is in meters per second. Change in velocity is, acceleration is meters per second squared. Change in velocity is meters per second, and time is in seconds. And time in seconds is really important. Okay, if time is not in seconds, it must be converted to seconds. Really, really important. Okay, we're going to have a look at an example and put this equation into practice. A cheetah sees an African savanna hare and it gives chase. The cheetah accelerates from breast and reaches a top speed of 20 meters per second. It takes the cheetah 2 seconds to catch the hare. Calculate the acceleration of the cheetah. I've highlighted a few key terms there and information for you to pick out from the question to help you answer the question. If anything is at rest or stationary, then the velocity is 0. So rest or stationary, velocity equals 0. Okay. The change in the velocity is always the final, take away the start, the initial. Okay. So calculate the acceleration. It's asking you to calculate the acceleration. The equation is the change in velocity over the time. Change in the velocity, like I said, is final, take away, starting. Final velocity is 20, take away 0 is 20 meters per second, and the time is 2 seconds. We divide those and we get our answer of 10 meters per second. Remember to always have the unit. What I would like you to do now is work your way through that table. Pause the video and remember you're just working out the acceleration for 1 to 5 and using the equation acceleration equals change in velocity, which has been given to you, divided by the time. So pause the video now and make your way through those, and unpause it and I'll go through the answers with you. Okay, using a different coloured pen, mark these. So acceleration is change in velocity divided by time. 10 divided by 5 is 2 meters per second squared. Number 2, acceleration is change in velocity divided by time. So 300 divided by 6 is 50 meters per second squared. Acceleration is change in velocity divided by time. 7 divided by 0.7 gives you 10 meters per second squared. Change in velocity over time, 25 divided by 50 is 0.5 meters per second squared. And 120 divided by 40 is 3 meters per second squared. When it's like this, it is really straightforward. However, we do know that in science, the questions are a lot wordier. So therefore, that's what we're going to have a look at now. I'm going to go through the first one with you, and then you can pause the video and make your way through questions 2, 3, 4 and 5, and then we'll go through the answers together. Okay, Question 1. A missile changes its velocity from 100 meters per second to 500 meters per second in 4 seconds. What is its acceleration? So it tells you the starting velocity and it tells you the final. And we know that the change is equal to the final, take away the starting. Okay? So you would work that out first. 500 minus 100 gives you 400 meters per second. Then you would write down your equation. So acceleration equals change in velocity over time. Change in velocity is 400 divided by 4 is 100 meters per second squared. It is not enough just to write down the answer here. Okay? You must show working out. Really, really important. Pause the video now and make your way through questions 2 to 5. Okay, hopefully you've managed to make your way through those questions. I'm now going to go through them with you. Mark them in green pen and add any corrections that you need to do. A sprinter increases his velocity from 2 meters per second to 12 meters per second in 5 seconds. What is his acceleration? So again, this is the start and this one here is the final. So final. So we work out our change in velocity. 12 take away 2 is 10 meters per second. Write down our equation. 10 divided by 5 gives you 2 meters per second squared. The parts that are highlighted in green are showing you where you would potentially get marks in a test. So showing you the areas that examiners look for when we are marking exams or tests. So this shows that you've worked out your change in velocity and that you understand that this part of the equation means change in velocity. You haven't just picked out a number. This shows that you can input the numbers and come out with the right answer. If you were to do 10 divided by 5 and you came out with 50 and the exam question was worth 3 marks, you would get 2 out of 3 because you have shown all your working out. If you were to just write 50, you would get no marks. Hence why it is so important that you must show all your working out. Okay. Question 3 is slightly different and may have caused a little bit of confusion, but let's see how we got on. So, a car slows from 10 meters per second to 0 meters per second in 5 seconds. Okay, what is the car's deceleration? So it tells you that it's slowing and then it tells you that it's decelerating. If it's decelerating, the acceleration will be a negative number. So deceleration will be a negative number. Okay. Really important that we are aware of that fact. So, the final velocity is 0 because it slows from 10 to 0. The starting velocity is 10, so you end up with a negative 10 meters per second for your change. And that's fine because the car is slowing down. Still using the same equation, inputting the numbers, and your answer is minus 2 meters per second squared. If you got that right, well done. If you didn't, don't panic. We will have a look at some more of these during the review feedback lesson. but it's just really important to know that its deceleration is always a negative number. A cheetah starts from rest and reaches a velocity of 30 meters per second in 4 seconds. What's the acceleration? The final velocity you should have as 30. The starting velocity is rest, so therefore rest is equal to 0 meters per second. So 30 take away 0 is 30. Acceleration is change in velocity over time. 30 divided by 4 is 7.5 meters per second squared. Don't let the fact that there's no number for this starting velocity throw you. Anything at rest, it will always have 0 meters per second. A Porsche can reach a velocity of 12 meters per second from rest in 3 seconds. What is its acceleration? Again, rest is 0 meters per second. Your equation is your change in velocity over time. Change in velocity is 12, take away 0. 12 divided by 3 is 4 meters per second. Okay. If you're still not sure doing these examples, feel free to email me. I will put my email at the bottom, at the end of this video, and I can give you some more examples to work through until you are confident. Okay, I want you to have a look at the table with this table here. I've covered it because I have some answers that I don't want you to have a look at. But what I do want you to do is have a go at number 2 and number 4. So the rocket and the car braking. The rocket and the car braking. Number 1 and number 4. Just to give you an additional practice at doing the examples. So pause the video and do the rocket and the car braking, please. Okay, hopefully you've managed to make your way through those. The rocket was asking you to work out the acceleration. I'm just going to write on this piece of paper that is here for me. So the rocket was asking you to work out the acceleration. So the change in the velocity is your final, take away the start. It's now out of range of my camera. Final was 750, take away 450 equals 300 meters per second. And the time it took was 100 seconds. So your answer should be 3 meters per second squared. The aeroplane, was it? Yeah. The aeroplane was slightly different, and there are 2 ways that you can do it that I'm going to show you now. So, sorry, I've just got this on another piece of paper for you to have a look at. Okay. So there are 2 ways that you can do number 4, and I'm going to talk you through both ways, and it just depends what way works for you. Both ways get you the same answer, so don't panic if you understand one but not the other. The answer we're looking for is 6 seconds. So it tells you the acceleration is -5. So it means it's slowing or braking or decelerating. The time we didn't know. Starting velocity was 0 and the final velocity, the starting velocity was 30 and the final velocity was 0. So the change in the velocity is final take away starting, so 0 take away 30, which is negative 30. The equation that we've been working on is acceleration is change in velocity divided by change in time, or the time. So the acceleration is minus 5. The change in velocity is minus 30 divided by time. We don't know how this minus 5 got there, but we do know that you divide by time on this side. So to get time on the other side, to try and get it on its own, i.e. the subject of the equation, we're going to multiply by time. So minus 5 multiplied by time equals minus 30. And to get time, the subject of the equation, you're going to divide minus 30 by minus 5 to get it on its own. So you always, when you're moving things around in an equation, you always do the opposite. So because it was divided here, we multiply it to get on the other side, and because it was multiplied here, we divide the minus 5 to get it onto the other side. Minus 30 divided by minus 5 is 6. The other way of doing it is rearranging the equation before you start. So I've got the same amount of information as I did previously. Okay. Acceleration minus 5, time we don't know, start is 30, final is 0, change is the final, take away the starting, 0 take away 30. Acceleration is change in velocity over change in time. Therefore time is change in velocity over acceleration. So I've just rearranged the equation here, and I've got same numbers, minus 30 divided by minus 5 gives you 6 seconds. So there are two ways you can do it. Obviously this way is a bit more complicated, and I appreciate that. This way you've got to know how to get from here to here, and you can use a triangle. So you've got your change in velocity, time and acceleration. You cover one over the one that you want, and it's change in velocity over acceleration. It just depends how you remember it. But you can see here that both ways gives you the same answer. Okay, I'm going to leave it there for now. And part 2 of this lesson can be found on a separate video, along with the knowledge check that goes with it.